Okay, so I did that without recording it, but we want to show that f is the self-inverse function, so that the inverse is the original function. So I switch x and y, and then I cross multiply here and distribute. Then I get the numbers, like the y's on one side, everything else on the other, factor out a y, and then divide. And then here I factored out a negative top and bottom, so that it looks like the original. Okay, so now hence find in terms of k the value of f at k, where k is not equal to 3. So if we have f of f at k, and f is a self-inverse function, this is the same thing as this. Okay, so this is just equal to k. The figure below shows a sketch of a one-to-one function defined over the domain (-2 to 2). The graph of y equals g at x consists of two straight line segments, and the range is that. Find the value of f of g at (-2). Okay, so this is g. So g at (-2) is (-5). So this is f at (-5). So we just need 3 times (-5) minus 1 over (-5 minus 3, which is (-8). So that's (-16 over (-8), 2. Okay. On the same diagram above, sketch the graph of the inverse function. Okay, so this is where we just switch points. So (-2), (-5 is going to be (-5, (-2). And then we have (-1, 0), so 0, (-1). And we have 0, 2, so 2, 0. And we have 2, 6, so 6, 2. And then we can connect that with lines. Okay, so here, and then those should be on a straight line. Yeah, not bad. And then the domain is the range of the original. So the range of the original is (-5 to 6, and you can see it's (-5 to 6). All right, so the domain is this. So for 42, the function's defined by that. The function g is that. Find the value of a greater than 0, and the corresponding value b such that f of g at x is that. Okay, so if we have f of g at x is 4x squared plus 6x minus 3/4, and we want to, so we could do f inverse of all of this. But then we would have to find the inverse of f, and it's quadratic. So if we instead do like this, because that's just linear g inverse, and then we'd have 4 like this, 6g inverse minus 3/4. And then we can set the things equal to each other. So the inverse of g, in terms, with 0 numbers, we're going to have x minus b over a. That's the inverse, okay? So we're going to have 4 x minus b over a squared plus 6 x minus b over a minus 3/4. All right, and we know this is going to be equal to f. All right, so f is, if we expand that out, it's going to be x squared plus 4x, plus 4 minus 3, so plus 1. All right, if we expand this side out, we're going to have 4a squared on the bottom, And we're going to have x squared minus 2bx plus b squared plus 6x minus 6b over a minus 3/4. All right. And then we're going to distribute this. So we're going to have 4 over a squared x squared. And then minus 8bx over a squared plus 4b squared over a squared plus 6x over a minus 6b over a minus 3/4. Okay. Now, we know that this is going to be equal to 1. There's only one x squared. So we've got 1 equals 4 over a squared. So cross multiplying, you see a is plus or minus 2. And it says a is greater than 0 up here, so we have a equals 2. All right, now what's an easy one? So we have negative 8b over a squared and 6 over a. That's our x coefficients, and that's going to equal 4. Okay, so a is 2. So we're going to have negative 8b over 2 squared, which is 4, plus 6 over 2, and that's going to equal 4. So we've got negative 2b plus 3 equals 4. So subtract 3, which equals 1. So b is negative 1/2. And we're not done yet. So b, the functions h and k are defined by that. Respectively, find the value of c such that h at kx has equal roots. Good questions. So h at k is going to equal 5, and then we substitute in k, cx squared minus x plus 2 plus 2. And if we do this out, we have 5cx squared minus 5x plus 10 plus 2, which is plus 12. So then we want them to have equal roots. So that's discriminant. And b squared is 25 minus 4ac. Equal roots means one root, basically, because remember it's like that. Okay, roots on the line. Okay, so we've got that 25 minus 20c times 12 is 240c equals 0. Okay, so 25 equals 240c. So if we do c is 25 over 240, and we can simplify, divide by 5, and 5 goes into that 48 times, so that should be c. All right, so for this one, f is that, g is that, solve the equation. Okay, so we want to substitute f into g, so we're going to have square root of x plus 1 plus 1 squared, and we want that equal to 1. So if we distribute, we're going to have x plus 1 plus 2 times the first and the last, times 1 doesn't matter, and then plus 1, and that equals 1. So here we're going to have x plus 1 plus 2 root x plus 1 equals 0. And then if we subtract negative 2 root x plus 1 and then divide by negative 2 and square both sides. Okay, so that's going to be x plus 1 on one side, x squared plus 2x plus 1 over 4, and then cross multiply, and then subtract, and minus 3, and then factor, minus 3 and plus 1. So x is 3 or x is negative 1. So if you look at the original function, the domain, the g at x is fine. You can substitute anything in there. But for f, we have x plus 1 has to be greater than or equal to 0. So x has to be greater than or equal to negative 1. I'm not sure why in the mark scheme it's saying x is just negative 1. But, yeah. Okay, so find the inverse in simplified form. So we're going to have x equals root y plus 1 plus 1. And we should subtract 1 first and square both sides. And then subtract 1. And that's the inverse of f. Okay. Find the function h given that h of f equals g. So h of f equals g. And we want to find h. So we need to do h of f inverse. So g of f inverse. And that solves for h. So we need g and substitute the inverse in. So that's going to be x minus 1 squared minus 1. All of that squared. Okay. And that's for c. And if we want d, we have find k. Okay, so we need to do f inverse of f of k, f inverse of g. So that will have k equals, substituting g, x squared, into the inverse of x. So we're going to have x squared minus 1 squared minus 1. Goodness, last one, 44. Following diagram shows part of the graph of that defined by that. Find the expression for the inverse. Okay, so x equals 1 plus root y, subtract, and square. And we have, state the domain and range of the inverse. Oh, this should have been squared. So the range, so this is the domain, so that's the range. So y greater than or equal to 0. The range of this, you can see from the graph, is y greater than or equal to 1. So we're going to have x for the domain here, x greater than or equal to 1. And then c, on the same diagram, sketch that. So we have 0, 1, 1, 0, 1, 2, 2, 1. What's another point? 4, 3, 3, 4, and that should be good. And you can see x greater than or equal to 1 and y greater than or equal to 0 is the domain and range. And then find the exact value of the solution. Okay, so no calculator. So we have 1 plus root x equals x minus 1 squared. Okay, so I'm going to expand this out. X squared minus 2x plus 1, and then we're going to minus that 1. So then we will square both sides. So we're going to have x equals, those cancel, x squared minus 2x squared. So we are going to have x to the fourth minus 4x cubed plus 4x squared. And then we have this mess. And then we can factor out an x cubed minus 4x squared plus 4x minus 1. So x is 0, or we can't solve a cubic. So we have to, so remember that one problem where we had the graph and we wanted to find when the functions equaled, and we just saw where it intersected the line y equals x. So we can set either f at x or the inverse equal to x. Okay, so we're going to have square root x equals x minus 1. Square both sides. So that's going to be x squared minus 2x plus 1. So x squared minus 3x plus 1. And if we want the exact solution, we have to use quadratic. So negative b plus or minus the square root. B squared minus 4ac is just 1 all over 2a. So 3 plus or minus root 5 over 2.